Hi, and welcome to a short tutorial on factorising quadratics through a method called completing the square. So what I'd like to do is actually finish these perfect squares. So this is, you can see up here, what we've got is a quadratic, but it's incomplete. We're missing the third and final term, which if you've recognised perfect squares before, you might recognise that the third term is generated by half of the coefficient of the second term. So in this case, half of 10 is 5, and then we square it. So what we've got here now is a perfect square, which can be expressed in the form of x plus 5 all squared. Now if I was to expand this out, I'd get back to this point here. So let's look at a couple more and see what happens. So again, I want to find the third term for this. So I take half of the coefficient of the second, so 10, and I square that to give me 100. And this now can be expressed as x plus 10 all squared. Now I can complete the others, and I'll allow you a bit of time to do that, but I want to go down to this bottom one just to show the effect of the negative. So again, we take half of the negative 16, which will be negative 8. But of course, when I square a negative 8, I'm going to get positive 64, which can be expressed as x take 8, or my negative 8, all squared. And I've actually finished those squares, and here you can see there's some answers to them. So I'll just take you back a bit. If you'd like, pause the video here, complete the rest, and then check on with the next answers. Okay, here are the answers. Again, pause the video and make sure you've got them right, and then move on. Okay, here are a few that are written as a perfect, or as a trinomial, so as a quadratic, so it's got the full three terms, but you'll notice they're not perfect squares. What I'd expect here, if I was to complete the square, I'd take half of that 10x, which is 5, and I'd expect a 25 in this instance. As you can see, I've got 29. So what I can write here is I've got x squared plus 10x plus 25 plus 4 more to give me 29, which is what I had here originally. This can then be written in this form here, where I've got a perfect square, which can be expressed as x plus 5 all squared, plus the 4 more. And now I've written that as a perfect square. I'll do a couple more to see how we go. So here, looking at this one, if I was to take half of my 20, I'd get 10, and if I squared that, I'd get 100. Instead, I've got 103, so what I'll do is I'll write it as x squared plus 20x plus my 100 plus 3 more. So that gives me my 103. Looking now at the first three terms, these can be expressed as a perfect square, as x plus 10 all squared plus 3. And so this expression here, the first expression, can now be written in this form here. In other words, what we can do is we can take something which is in the ax squared plus bx plus c form and turn it into the turning point form. So choosing another one of these, let's have a look at the third one. So here, if I was to half this term, I'd get 1. If I was to square 1, I'd get 1. So here I'm expecting it to be x squared plus 2x plus 1. But I've got to get minus 1 all up, so in fact I've got to subtract 2 in this instance. So what you'll notice is 1 take 2 here gives me my negative 1, which I actually started with. So we've still got the same expression, we're just writing it in a slightly different fashion. I'll again take those first three terms and express them as a perfect square, which is x plus 1 all squared, and then I'll take my 2 away. So again, an expression in the form ax squared plus bx plus c can now be rewritten in the form better known as the turning point form. Okay, you might wish to pause this video once more and see if you can complete the rest, and once you've done that you can check on your answers. So here are the answers now. Just check to see that you've got them all correct, and we'll move on. Okay, and now probably more in the form that you'll see some of the questions in the tests or exams that you might come across. you'll be asked to change the quadratics into a turning point form by using the method of completing the square. So it gives you both what you're to do, which is change from one form to the other, from a standard ax squared plus bx plus c form into the turning point form, and if you're fortunate enough, it might give you a bit of a clue that the method of completing the square is the way that you want to go. So I'll suggest that you pause here, practice those, and once you've practiced those, release the video and you can check the answers. Okay, thanks. I hope that's helped.